Today we are going to talk about loops, and we're not going to add any code to our person class, but we are going to look at some demonstration code. So feel free to type along as I type. If you just want to watch me and learn what loops do, that's also fine. We really won't get to see what loops are really geared for until tomorrow whenever we talk about arrays, because arrays and loops go hand in hand. And loops on their own can be useful. I'm just not very good at thinking of a particular instance of when they are. But whenever you think of the word loop, you kind of get in your mind a circle-like shape. It's something that goes around and around and around and around. You know, it loops and keeps going and going and going. Well, that's basically what a loop is in programming. It is something that executes one or multiple lines of code for an arbitrary amount of time. And that time is usually dictated by a condition. As long as the condition returns true, that loop is going to continue to execute. And each execution is called an iteration. So a loop will iterate as long as a condition is true. And then when the condition is false, the loop exits. So let's start by talking about a for loop. If you were going to translate a for loop into a spoken language, you would say something like this. I am going to execute these lines of code for a certain amount of iterations. Notice the word for, and there's also something for a certain amount of iterations. That implies that the for loop is a counter-based loop, and that would be a correct implication to make. The structure of a for loop is somewhat confusing at first, but whenever you start to use this more often, and not just in C#, but in C, C++, Java, JavaScript, PHP, they all follow the same structure. So once you learn it with C#, you can use it in just about any other type of language that is built off of the C language. So we start off with for. And then we have a set of parentheses, and inside of the parentheses are three things that the for loop needs in order to function. The first is the initialization, and it's usually the initialization of the counter. So the most common counter is just a number to count the iterations that the loop goes through. Next is the condition, and if the condition is true, then the loop will continue to iterate. If it is false, then the loop will exit. So the condition determines how many times we are inside of this loop. And then last is the incrementation, and that is the incrementation of the counter. At least that's what it's usually used for. So every time the loop iterates, it has to execute the code for the incrementation portion, because that increments our counter, which essentially gets us out of the loop eventually whenever we meet or whenever we get a false value for the condition. Now notice between these three things are semicolons, and those are required. That's how the compiler knows to separate the initialization from the condition from the incrementation. And of course, there is a code block after the parentheses. So let's go ahead and actually write a for loop. So we'll have for, and then our parentheses, and then inside we need the initialization. So I will create a variable called counter, and I will give it a value of 0. Now remember, whenever we talked about strings and indexes and how we need to count from 0, the same thing is going to be true here. Sometimes we do want to start counting at something other than 0, but most of the time we want to start with 0. Next is the condition. Let's say for this loop that we want this loop to go for 10 iterations. So we would do counter is less than 10. We could also do counter is equal or less than or equal to 9, but for the most part, we just usually do less than 10. And this is a little bit clearer. I know we start at 0, but whenever we see less than 10, we kind of know, okay, well, we're going to go through this 10 times. The same would be for 20, and that's a little bit more clear than saying is less than or equal to 9, because it kind of gives us an idea of, oh, we're only doing this 9 times, but whenever we see that counter starts off at 0, then we are like, oh, okay, that's 10. But it's a little bit more explicit if we just say less than 10. Next is the incrementation, and we need to increment our counter. Now we can do that with counter equals counter plus 1, but there is an operator called the increment operator that we can use, and that is plus plus after the variable name. Now, before we go on, we do need to talk a little bit about this increment operator, because it does essentially mean counter equals counter plus 1, but there is some you might think irregular behavior the first time you deal with the increment operator, and it's not just a C# thing, it's just about every other language that has this increment operator. Let's create a variable called I and give it a value of counter plus plus. So after the line 28, this line right here, after this executes, the value assigned to counter is 1 because counter is 0 and we get counter plus 1, so 0 plus 1 is 1, and then that value is assigned to counter. Now let's say that this line does not execute at all, so all that we have is this line here on line 29. We have counter plus plus. Well, what this actually does is the value of counter, which is 0 at this time, gets assigned to I, so I equals 0. But then the increment operator executes and increments the value of counter. So counter is at 0, it increments by 1, so counter is then 1. So we have I, which contains 0, and then counter, which contains 1. So the two don't match up. But we can put the increment operator before the variable name, and this performs the increment before the value of counter is assigned to I. So in this case, we have the plus plus, so it increments counter to 1, and then that value is assigned to I. So in this case, I is 1 and counter is 1. So just so that you know the difference between putting the plus plus before or after the variable name does cause a difference in value if you are assigning that value to a variable of some type. Normally, though, if you're going to use the increment operator in a for loop, the counter plus plus is going to be fine. Now there's something else. I'm using counter here to be just explicit as to what this variable does. Most of the time you will see the variable I, and that's just kind of convention. You can follow that if you want, or you don't have to. It's completely up to you, but most developers use I. I personally use II, and this is something fairly recent to me, but it makes sense whenever it was explained to me. If you do a search for I throughout your code, you are going to find a lot of hits because I is a very common letter. Just looking through here, collections, generic, link, my first project, my first data types. I can keep going. We will find I in many lines of code, but we won't find II. So if I'm looking explicitly for these counter variables that I have, I can just do a search for II, and that would come up just fine. But for the sake of these demonstrations, I'm just going to use counter. Okay, so as long as our condition is true, the code inside of this code block is going to execute. Now, it can be no statements like we have here, and that would be fine. We can also have one or multiple statements. It really doesn't matter. Just whatever we define inside of this code block is going to execute for each iteration of the loop. So let's write something to the console. Let's write line, and let's write the value of counter. So we will be counting from 1 or from 0 to 10, but if we wanted to actually do it from 1 to 10, we could just take counter plus 1. Now notice we are not assigning a value to counter, we are just taking the value of counter and plussing 1 to it. So whenever we run this, we are going to see 1 through 10. Now that's a little bit misleading, but as far as our users are concerned, they're used to seeing 1 through 10 instead of 0 through 9. So you might want to keep that in mind whenever you are writing code for using loops and needing to display counter information to the user. So that's the for loop, and it can be a little confusing until you understand the initialization, the condition, and the incrementation, and you use it over and over again. But once you do that, it's very simple to use, and you would want to use it if, one, you need a counter for whatever reason, and there are sometimes you will want a counter, and 2, if you know how many incrementations you are going to go through. Now, you don't have to hard code a value here. You can use some dynamic data, although this particular data isn't so dynamic. Let's do hello first. But let's assume that the value assigned to hello actually came from the user, from some type of input, and it could be anything. It could be an empty string, or it could be 1,000 characters long. We really don't know, but we need to iterate over each of those characters within our code for whatever reason. And to do that, we could just simply do hello.length. This will get the length of the string as we used in one of the earlier lessons. So the counter will increment until we reach the length of the hello string. So we should have 13 characters here. So whenever we run this code, we should have 1 through 13. And there we go. So it's not something that you have to hard code in. It can be something that you can get via a property or a method or something like that. So the for loop is handy in those two situations, when you need a counter or you know how many iterations you need to go through. But sometimes you don't need or want that information. Sometimes you just want to do a loop while a condition is true. And that's where another loop called the while loop comes from. And if you were going to translate that into a spoken language, you would say, I want to execute these lines of code while something is true. So we start a while loop with the while keyword, and then a set of parentheses, just like the for loop, but instead of having the initialization, the condition, and the incrementation, all we have is a condition. So as long as the condition is true, the loop is going to iterate. Otherwise, it's going to exit. So in this particular case, we have specified true. Now, true will never change because, there's nothing here. We have hard-coded true, so we have put ourselves into an infinite loop. And what that means is we get into a loop that will never end. And those can be exceptionally dangerous, especially if you're working with data and you don't mean to, but you end up corrupting that data. So it's always important to be mindful of your conditions, and with the for loop, your incrementations, because you can just as easily create an infinite loop with the for loop than you can with a while loop. In fact, let's go back and get that for loop there. We could just do counter equals 1, and this is going to put us into an infinite loop because this incrementation executes with each iteration of the loop. So every time the loop iterates, we are giving the value of 1 to counter, which is always going to be less than hello.length. So whenever we run this, we can see that, here we go. We are in an infinite loop. You can see how this is blinking here. It's just keep writing 2 and 2 and 2 and 2. So this is, while not very dangerous for this particular thing, as I said, if you're working with data from a database or a file, you can corrupt information very easily if you're not careful by getting into an infinite loop. So be mindful of that. So back to while. Let's get rid of this. While this is true, now of course this is going to put us into an infinite loop, so we obviously want to put a condition here that will eventually be false. So let's demonstrate a while loop by doing a replace. We will replace the else inside of hello world with just an empty string. Now of course we could do that very easily using the replace method, because we can specify, okay, replace all the else with an empty string. And yeah, that would work, but that doesn't help us with this demonstration. So we are going to write our own type of logic for replace. So the first thing we need to do is get the index of the else. So let's create a variable called index. That needs to be an integer. Index equals hello index of L. So this is going to return 0, 1, 2, the value of 2 to index, because that is the first index of L inside of our hello string. And as long as index is is greater than -1, then we want to do something inside of the loop. Now remember that index of will return -1 if it doesn't find whatever we specify. So if there are no L's inside of hello world, index will contain -1. Now, before we do anything inside of the loop, the first thing we need to do is write the last line of our loop, and that is to give index a new value. Because if we are inside of this loop, then an L was found. We are going to replace it with an empty string, and then we need to get the index of the next L. So now we just need to write the code to replace that L, and we will do that by saying hello equals hello, and instead of doing replace, we are going to do remove. The start index is the index that we have specified. The count is 1. So after this loop exits, let's write out the new value of hello. And we should see a string that contains hello world without the L's. So here we go, and heo word. Yeah, well, that obviously worked. So that's a while loop. We loop while something is true. Now, one thing about the for loop and the while loop is that we may never iterate at all. We might get a condition that is false from the very beginning, therefore making the loop exit immediately. Just to demonstrate this, let's get rid of the L's within our hello world. So whenever index of executes, a value of -1 is going to be assigned to the index variable because there are no L's. So when the condition is evaluated of the while loop, it's going to check to see if -1 is greater than -1. Well, that's false. So the loop is automatically going to exit. And just to show you that that is what it's doing, let's write something. We're in the loop. And then whenever we execute this, all we will see is the value of the hello variable. See, we don't get the where in the loop because it exits immediately because that is false. Now, there are some times when we want a loop to iterate at least once. We want one guaranteed iteration. And it's not common, but there are some times that we want to do that. And for that, we have a DoWhile loop. And it's kind of the same premise as the while loop, except that we have a portion called do. It's a code block, and then we put the code that we had inside of while inside of do. While doesn't have a code block, and in fact, it just has the condition after followed by a semicolon. So in this case, the code inside of do executes at least once, and then the condition is evaluated. So as this happens, we are going to get an exception because we have a value of -1 assigned to index, and we try to remove a character at an index of -1. Well, there is no such thing. The index starts at 0. So we are going to get an exception because we are going through at least one iteration. And there we go, an unhandled exception. And that's never good to see. So in this case, we always want to make sure that if we have a guaranteed iteration, that we make sure that there are no errors that occur within that iteration. The last loop is a ForEach loop, and it's used pretty much only with arrays or array-like structures. And we have a string. A string is actually an array of characters. So if we wanted to use a ForEach loop on our hello string, and let's go ahead and add the L's back, we would translate that into our spoken language as, for each character in our string hello, we want to perform the following lines of code. So let's type that. The ForEach loop starts with for each, and then we have open parenthesis. Now we don't have a condition here. We are using a ForEach loop to loop over each item within the array. In this case, our array is this hello string, and each item in this array is a character. So for each character, and we have to define that character, C, in hello, we want to do these things here. And we just want to write line C. So we will see hello world written out vertically. every line will have its own character starting with H, and then the next line will have E, and then the next line L, and then so on and so forth. So let's go ahead and write that. Let's comment this last line. And there we go. Hello, comma, space, world. So with the ForEach loop, we can iterate over whatever array it is that we are wanting to loop over and look at each of those items inside of that array, just like we have done here. We have looked at every character inside of the string hello. Now we could actually just do write, and instead of writing each character on each line, we will see it all on one line. Hello world. Of course, press any key to continue is there. So at the end, we could just do console.writeLine string.empty. And then that will put that on a new line. So there we go. Now, of course, it would be infinitely easier just to do console.writeLine hello instead of looping over each character inside of the string. But this at least demonstrates the use of a for each. And we will see for each used either today or either tomorrow or the next day. So anyway, those are the loops that we have at our disposal. They are primarily useful for arrays, and we will see that whenever we talk about arrays tomorrow. So have a great day today, and I will see you tomorrow.